Today's honors geometry lesson is on square roots and radicals. The objectives are to simplify radicals and rationalize the denominator in order to simplify radicals. A number x is the square root of a real number b if and only if x squared is equal to b. A square root of a number is one of two equal factors of that number. This symbol here is called the radical sign. And the number underneath the radical sign is also known as the radicand. So let's review the square roots of perfect squares. So remember that the square root of 64 is 8, since 8 times 8 is 64. Let's look at a second example. So remember that the square root of 49 is 7, since 7 times 7 is 49. And let's take a look at a third example before you try some on your own. So the square root of 16 is 4, since 4 times 4 is 16. So at this time, stop the video, work through the rest of the perfect squares, and when you're ready to see the answer, start the video again. So how'd you do? If you have any questions on the square root of perfect squares, go ahead and stop the video again, re-look at the question, and make sure you know how to answer it. If not, come in tomorrow with any questions and I can help you. If an integer is not a perfect square, the square root of the integer is irrational. It cannot be written as either a terminating or a repeating decimal. Root 3 is an example. Such square roots can only be approximated using decimal numbers. So when asked to find the exact answers, you will write the radical form rather than the decimal approximation. So here's how we simplify radicals. We will simplify radicals by removing the factors of a perfect square from under the radical sign. This requires the use of the product of property of radicals. The product property of radicals states that if you have a number, you may break that number up into two different radicals, one being a perfect square and one being the second factor that multiplies to the original root. So let's take a look at the first example, which is root 15. So root 15 can be broken up into root 3 times root 5. And as you can see, root 3 and root 5 do not contain perfect squares, so therefore we know root 15 is simplified. This also works backwards. So you can take root 5 times root 11 and turn that into root 55 in order to simplify. So we know that root 55 does not contain any perfect squares since 5 and 11 do not contain perfect squares either. So one more example. So if we take root 21, we can turn that into root 3 times root 7. And again, since root 3 and root 7 do not contain any perfect squares, then we can say that root 21 is simplified. So if we look at the fourth example, so root 18. So if we look at root 18, we're looking to see if there are any perfect squares contained in root 18. And we know that 9 times 2 equals 18. We also know that square root of 9 is 3. So therefore, we can actually simplify root 18 to 3 root 2. Let's work through a couple examples using the first radical rule, which says that you may not leave a perfect square factor underneath the radical sign at any time. So if we look at root 8, we know that root 8 has the factors of 4 times 2, and the square root of 4 is 2. So we can simplify this into 2 root 2. Let's do one more example before I let you try some on your own. So for root 20, we want to know if this is simplified. So we know that root 20 is the same thing as saying root 4 times root 5. Since root 4 is a perfect square, we know the square root of 4 is 2. So root 20 can actually be simplified into 2 root 5. At this time, I would like you to stop the video and try examples 6 through 10 on your own. And when you're ready to check the answer, start the video up. So take a look at the simplified radicals underneath or in the boxes. If you weren't able to get these answers, go ahead and stop the video again, take a look at the work, and if you still have questions, come in and see me tomorrow. So I want to take a look at examples 11 and 12, which are slightly different because we're taking one radical times the second radical. So what you want to do first is you want to go ahead and simplify the radicals down as far as you can before you multiply. So we know from example 4 that the root 8 simplifies into 2 root 2. And from example 5, we know that root 20 simplifies into 2 root 5. The rules for multiplying radicals states that you may multiply numbers outside the radical with other numbers outside the radical, and you can only multiply numbers under the radical with other numbers under the radical. So if we take 2 times 2, since they're both outside the radical, that will give us 4. And then if we take root 2 times root 5, that gives us root 10. And this is our simplified radical. For 12, if you notice, root 5 and root 15 do not contain any perfect squares. So our first step is to go ahead and multiply. So 3 times 2 is 6, and then root 5 times root 15 is root 75. So what I want you to look at is root 75. So if we look at our factors of root 75, we know that that contains a perfect square of 25, and that 25 times 3 is 75. So we can actually simplify this one step further. So we know that the square root of 25 is 5. And now that we have 6 and 5 outside the root sign, or outside the radical, we can now multiply and simplify this into 30 root 3. Our second radical rule states that radicals in a denominator of a fraction are not correct math etiquette. So what we want to do is remove any radicals from the denominator of a fraction by doing what we call rationalizing the denominator. So if a fraction has a simplified radical in the denominator, we're simply going to multiply the numerator and denominator of the fraction by that radical. And this is the process called rationalizing the denominator, which helps us to remove the radical from the denominator, but doesn't actually change the value of the fraction. So in example 13, we have 2 divided by root 3. Since root 3 is a radical and it's simplified, we can rationalize the denominator by multiplying both the numerator and denominator of the original fraction by root 3. So if we multiply straight across, we have 2 times root 3, which is 2 root 3. And then root 3 times root 3 is root 9. So now if we actually simplify root 9, we know the square root of 9 is 3. And therefore, we have not changed the original value, but we were able to get the radical outside the denominator. For example 14, even though there's a radical in the numerator and a radical in the denominator, the process is exactly the same. So root 7 is a simplified radical. So to get rid of that, we are going to multiply both the numerator and denominator by 7. So root 5 times root 7 is root 35. And then root 7 times root 7 is root 49. And we know that the square root of 49 is going to be 7. So in example 15, we're going to go ahead and do the same thing. So we have root 2, and we know that root 2 is simplified. So we're going to multiply the numerator by 2 and the denominator by 2. So root 10 times root 2 is root 20. And then root 2 times root 2 is root 4. Now take a look at the numerator. We always want to make sure we're completely simplified. So we know from the previous slide that root 20 actually simplifies into 2 root 5, and that the square root of 4 is 2. The last thing we want to do, just like multiplying, you can multiply a number outside a radical by another number outside the radical, so you can also simplify fractions the same way. So since I have 2 in the numerator and 2 in the denominator, we can reduce and say that 2 root 5 over 2 reduces to just root 5. So in the last example, we have a number outside a radical and a number inside the radical in the denominator. So remember, the rule says to rationalize the denominator, you only multiply by the radical. So even though we have a 5 there, we're only going to multiply the numerator and denominator by root 3. Okay, so 2 times root 3 is 2 root 3. We're going to carry over the 5, and then root 3 times root 3 is root 9. So if we continue to simplify, 2 root 3 is simplified. This turns into 5 times the square root of 9 is 3, and 5 times 3 is 15. So 2 root 3 over 15 is our simplified radical. The last thing we're going to take a look at today is the quotient property of radicals. This tells us that if we have a fraction underneath a radical, we can break up the radical and turn the numerator into its own radical and the denominator into its own radical. So if we look at example 17, we have the root 10 over 9. So we can go ahead and take the numerator and say this is root 10, and then turn this into root 9. And then we can use our rules for simplifying to rationalize that denominator if possible, or if we need to. So in this case, we know that root 10 is simplified. There are no perfect squares in 10, but we do know that root 9 simplifies into 3. So in this case, there's no need to rationalize the denominator since we do not have a radical in the denominator. So for the second example, so example 18, we're going to go ahead and split this into root 18 over root 25. Okay. So root 18 can actually be simplified from the previous slide, so we know that it's 9 times 2, so 3 root 2, and then the square root of 25 is 5. So this is just a way to help us simplify when we have a fraction underneath a radical. So this leads us into our last radical rule, which says that no fractions can be left underneath a radical. So for 19, we're going to start off by using the quotient property of radicals. We're going to turn this into root 1 over root 2. Since root 2 is simplified and it's still a radical in the denominator, we're going to rationalize the denominator by multiplying both the numerator and denominator by root 2. So root 1 times root 2 is root 2. And then root 2 times root 2 is root 4, and the square root of 4 is 2. So let's just take a look at one more example. So root 15 over 18 can first be simplified into root 15 over root 18. Okay, so root 15 is simplified. There are no perfect squares. But we know from the previous example that root 18 actually simplifies into 3 root 2. So in this case, we're actually only going to multiply the numerator and denominator by root 2. So root 15 times root 2 is root 30. And then 3 times root 2 times root 2. So root 2 times root 2 is root 4. The square root of 4 is 2. So 3 times 2 is 6. Okay. So that's the end of the lesson for today. If you have any questions, feel free to watch the video for a second time. And if you still have questions on perfect squares or any of the 3 radical rules, make sure you write those down and bring them to class tomorrow.